Welcome to today's video. Today we're going to be focusing on solving multi-step inequalities. Again, we're going to show that mastery in class by scoring at least an 80% on the exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet and we'll get you a fresh one tomorrow. Now, when it comes to inequalities, there is only one difference from equations to inequalities. When you multiply or divide by a negative, and it's any negative number, you need to flip your sign. That is the only difference. Everything else stays the same. We still use inverse operations. We still want to bring the variable to the left, the constants to the right. Now, if you bring them to the right and the left opposite, that's fine. But we still want to solve them exactly the same way. We just need to divide when we have a negative. Now, if we look at our first box, we have 6 plus 2x is greater than or equal to negative 3 times 1 minus x. So, if I start my problem, the first thing I want to do, just like when we do equations, I'm going to put a 1 in front of the x to remind myself, and I'm going to distribute my negative 3 to both numbers. I get 6 plus 2x is greater than or equal to negative 3 plus 3x. Now, I want to bring my variables to the left, so I'm going to subtract 3x on both sides. Those cancel. I'm now left with 6 minus 1x is greater than or equal to negative 3. Well, since my variables are on the left, I'm going to bring my constants to the right. So I'm going to subtract 6 on both sides. I have negative 1x is greater than or equal to negative 9. From here, because negative 1 and x are being multiplied, I'm going to do the opposite, and I'm going to divide by negative 1. Now, because we are multiplying and dividing by a negative, my sign needs to flip. So now my answer is x is less than or equal to positive 9. Now, if we look at our other boxes, set builder notation. Set builder notation is just a way to write inequality symbols. We start with our bracket, and it's x bar, x is less than or equal to 9. And when we read it, it is x is such that, and in this case, x is less than or equal to 9. So my bar just means x such that, and it tells them what x stands for. And set builder notation, it's whatever variable. So if I have y, it would be y such that y is. Now, on my graph, I'm just going to put 3 points. I'm going to put 8, 9, and 10. If I look, it's less than or equal to, so it needs to be a closed circle. And when I do my line, if your variable's in front, you can point your graph to the way the arrow is pointing. However, always use a checkpoint. If I check 0, is 0 less than or equal to 9? Well, yes, it is. So I want to make sure I point towards 0. Because 0 is a solution, we want to point towards 0. Now, examples of solutions and non-solutions. Solutions just mean it fits the inequality. In this case, 0 works. We checked that on the last one. 8 is a solution. 9 is a solution. We could say negative 10 is a solution. There's infinite number of solutions. We just want some of them. For non-solutions, 10 is not a solution. 12 is not a solution. 100 is not a solution. It's anything that's bigger than 9. But be careful, 9 is a solution because it is less than or equal to. All right, if we look at our second example, again, we're going to start by solving this out. So I have 2 in parentheses, 1 minus x is less than negative 2x plus 1. I need to start by distributing my 2. So 2 times 1 is 2. 2 times negative x is negative 2x is less than negative 2x plus 1. Well, I want to bring all my variables to the left, so I'm going to add 2x on both sides. In this case, those cancel, but those also cancel. So I'm left with 2 is less than 1. Now, just like equations, you have to ask yourself, but make sure you know your symbols. Is 2 less than 1? Well, no, it's not, so there is no solution to this problem. And I'm going to put a note on here so we remember 2 is not less than 1. Now, if it said 2 is greater than 1, that is a solution. But because 2 is not less than 1, there is no solution. As far as set builder notation, we're still going to write it. However, you're just going to put the symbol for the empty set there. That just means there's no solution to the inequality. It cannot be solved, which means there's no graph and there's no solutions. That is all we can fill in if there is no solution. If we look at our third example, we have the negative out in front of our parentheses. So negative 5 plus 2x is greater than or equal to negative 3, 1 minus 2x. Now I'm going to distribute on both sides, and on this side I'm going to make sure to put that 1 there. Negative 1 times 5 is negative 5. Negative 1 times 2x is negative 2x. Greater than or equal to negative 3 times 1 is negative 3. Negative 3 times negative 2 is positive 6x. So now I'm going to bring my variables to the left. Subtracting 6x on both sides, those cancel. Negative 5 minus 8x is greater than or equal to negative 3. I need to bring my constants to the right, so I'm going to add 5 on both sides. Negative 8x is greater than or equal to 2. I'm going to divide by negative 8, and that should send a huge red flag off for you. We need to make sure we flip our sign. And we still want to reduce our fraction. So in this case, x is less than or equal to negative 1/4. We can have fractions in inequalities. It's still a number, so it still will work. Now, if we scroll up for our set builder notation, again, we need our squiggly. X such that x is less than or equal to negative 1/4. Now, the big thing here when it comes to the graph, they're not going to graph decimals. So I'm going to put on here negative 1, 0, and 1. Well, if I put negative 1, 0, 1, negative 1/4 as a decimal is negative 0.25. Well, that's between 0 and negative 1, so that's where my point is going to go. So now we need to check our work. Well, if I check it, again, plug in 0 for x, is 0 less than negative 1/4? So is 0 less than negative 0.25? Well, no, it's not. 0 is actually greater than it, so we're going to shade away from the 0. Because 0 does not work, we don't want 0 to be a solution. So when we look at our answers down here, 0 is already an example of a non-solution. We could say positive 1 is a non-solution. For solutions, negative 1/4 is a solution because it says less than or equal to negative 1. And we can keep going and going. If we look at our last problem, yes, there's fractions, but we still treat it exactly the same. So I'm going to distribute my fractions through, and you can use the calculator or do it in your head, but if you're doing it in your head, make sure you check it on the calculator. You get 6 plus 1x is less than or equal to negative 4 plus 2x. Bringing my variables to the left, I'm subtracting 2x on both sides. That gives me 6 minus 1x is less than or equal to negative 4. Well, then I'm going to subtract 6 on both sides. That leaves me with negative 1x is less than or equal to negative 10. Again, we want to get x by itself, so I'm going to divide by negative 1, which sets off a huge red flag. That tells me I need to flip my sign. So x is greater than or equal to 10. If we come up to set builder, it's x such that x is greater than or equal to 10. So when we go to graph it, again, I'm just going to do 1 point on either side of the number. I have 9, 10, and 11. Because it is greater than or equal to that line underneath it, we want a completely filled in circle. And x is greater than 10. Plug in a number. Is 0 greater than 10? Well, no. 0 is not greater than 10, so we're going to shade away from 0. Graphing it is super important because we want to make sure we know which way our solutions are going. So make sure you pick a point. And if you don't want to use 0, you can use any number. I just choose 0 because it's a neutral number. It's a very easy number to use. Now, we said 0 is not a solution. Other non-solutions, 9 is not one. When we talk about solutions, because it says greater than or equal to, 10 is a solution. 11 is a solution. If it just said greater than, 10 could not be a solution, but because it has that equals line underneath our inequality symbol, it does work. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.